We're going to go ahead and get started. Welcome to today's webinar, everyone, titled Incorporating Ergonomics into a Construction Safety Management Program. My name is Jessica Bunting. I am the CPWR host and tech support for the event. I'm just going to go over a few quick things before we get started. First, if you're having any technical difficulties, you can email me by responding to the WebEx reminder email that went out about an hour before the event. Or if you're logged in, you can just send me a message via the chat box. If they're not already displayed on the right-hand side of your screen, you can add the chat and Q&A panels by clicking on the associated buttons that appear toward the bottom of your screen when you move your mouse. If you're having trouble hearing through your computer speakers at any point, we recommend calling in using your phone instead. Just make sure that you either disconnect from the computer audio or turn your speakers down so you're not hearing everything twice. We will take time at the end of today's presentation to answer questions. You can submit questions at any time in the Q&A or chat box. We'll do our best to answer all of them at the end. And this webinar will be recorded. I will automatically email that link to everyone with a PDF of the slides following the event. The PI of this project and our presenter today is Dr. Anne-Marie Dale. Dr. Dale is an associate professor of medicine at Washington University School of Medicine with over 30 years experience in clinical management and work site-based prevention of musculoskeletal disorders. She has designed interventions specifically to address musculoskeletal disorders in the construction industry. And with that, I will go ahead and hand it over to you, Anne-Marie.
Thank you, Jessica, and thank you, CPWR, for allowing me to have the opportunity to present the culmination of 5 years of this project. I presented an introduction to this study in a webinar about 3 years ago. So here are some of the results. And I'd like to acknowledge my co-author, Dr. Bradley Evanoff, who was a strong contributor to this design. So today I'm going to present three objectives. I'm going to present the background of the problem, where the idea came from, and how the way I'm going to present it, why we're doing it that way. The second point is a model ergonomic program, which is still I think very much in formation. And the final thing will be to present a case study, which is where we actually develop the model ergonomics program with a single partner. So as background, I'm sure many of you on the call are here because you're very familiar with the problem of ergonomic injuries in construction. Construction workers suffer from high rates of non-fatal injuries, and as of 2013, they were 16% higher than all other industries, and those rates continue to remain high. Overexertion is the leading cause of all injuries across all industries, and in 2016, Liberty Mutual reported this to be a $13 billion cost. Overexertion is also the leading cause of injuries in the construction industry. But there are many construction tasks that involve other ergonomic risks, including, besides overexertion. These risks include forceful exertions, repetitive motions, awkward postures, and hand vibration. And if you think of any construction activities that you're familiar with, you can imagine which ones of these risks exist for that trade. Ergonomic hazards that are very common include the handling heavy loads, which often leads to those overexertions. But in addition to that, we also see some workers perform the same tasks repeatedly, such as hammering or even manual material handling of loads repeatedly. It could be repeatedly moving your arm back and forth, such as the bottom right picture on your screen, an individual who's spreading adhesive for floor laying. But very common in this industry is working in poor postures, and the two that you can see in these pictures, the bottom left shows an individual bent forward at the waist. Lots of work done at the floor level is performed in this posture, and oftentimes for prolonged periods of time. The other two pictures, the one in the middle on the bottom and upper right, are showing working with hands overhead. Again, often held up there for long periods of time, and these will create problems in the shoulder and neck. So these high physical demands in these construction work tasks lead to these musculoskeletal injuries. In the acute phase, they are often diagnosed as strains and sprains, but when they've occurred repeatedly over time, they're typically classified as chronic, and examples of chronic disorders might be bursitis or tendinitis and carpal tunnel syndrome. Most of these disorders are not visible to the eye. The rare exception is the picture in the bottom right side of your screen, which is knee bursitis, and that actually is a swollen area that protrudes from the joint. But these musculoskeletal disorders or injuries can occur in any body part, and they're most prevalent in the low back. We often see them in the neck and the upper extremity, including the wrist and the knee. So the solutions, or how we reduce these risks for musculoskeletal disorders, is through ergonomics. That is the science that leads to prevention or reduction in the physical exposures. Again, those were the forceful exertions, repetitive movements, hand vibration, and awkward positions. But there have been many ideas published through CPWR and NIOSH and other sources, and these are just a few examples of them. Many equipment manufacturers, tool suppliers are also in the business for creating such solutions. So the question begs, why do we continue to see such a problem in the industry? There's also a desire for following the hierarchy of controls, which is commonly known in industrial hygiene, and it applies here to the exposures, the physical exposures in ergonomics. We ideally want to eliminate all of the exposures, so that level of the control is actually not on your diagram, because once it's eliminated, I don't consider that part of the concern. But once an individual must perform a task that involves exposures that can put them at risk for sprains, strains, or overexertions, then we want them, the individual or the system, the contractor, to help the worker design the best practice to reduce as much as possible. The best control will be an engineering control, where we actually reduce the exposure by using a different device, an engineering device. Some of the ergonomic examples on your screen are a mechanical assist that might help a worker lift a load, or to use a scissor lift to raise a worker to a higher position so they no longer have to raise their arm up above their head. Those are engineering controls. A work practice is an activity that a worker must use in order to reduce their own risk. Here, using an extended handle tool or sharpening a blade so that they don't have to exert as much force to use the knife would be considered work practice. Administrative controls are done outside of the worker. Those are controls imposed by management, where the workers are often alternated, maybe sharing the work with a coworker, or they may be given the opportunity to take a break. And that, in turn, will reduce their physical exposures in the course of a single day or over time. PPE is the least effective control, and this is a control where the risk level does not change, but something is done to either aid the recovery from the exposure or to provide some sort of comfort or mask of the exposure. Examples related to ergonomics would be using stretch and flex, or using knee pads or anti-vibration gloves. So even though a PPE is a commonly used control, they don't provide nearly as much benefit to the worker as the higher levels of the control. These are some examples of problems and solutions that I discovered on a previous project. Up in the left side, we see an individual who's actually spraying a sealant on grout in a large area. This was a large dining area, and in order to do that, he had to bend his back to reach the to position the grout. The sealant. There was a very cheap solution, which was an extension that could be applied to the spray can, and that was a worker-identified solution. However, unfortunately, the day the individual had to perform this task, the solution, the extended handle, was not available. Having these devices available is important. They must be planned for and communicated in order to be available when needed. This is another example of a worker who must pull up old carpet from the floor. In the left picture, he's forcefully gripping the carpet and pulling with his hands manually and absorbing all of the stress of the task. On the right side, he's using an automatic carpet puller that basically has a machine that is pulling the carpet for him. This, again, was a worker-identified solution in this particular situation, and this individual was not able to use that the automatic carpet puller on the left for the activity on the left side because the carpet was old and it fell apart as he was trying to use the automatic carpet puller. So sometimes there are great solutions, but they can't be used in all situations, and we have to find alternative means that maybe are not as ideal. During that project that I just showed you, those two solutions, we found a lot of barriers to using ergonomic solutions. Construction by nature is very challenging. There's unstable crews with high worker turnover. So finding and educating the same workers to perform a task might be challenging. There's also they frequently change their tasks even within a single day. So being able to plan for all the tasks they may need to have equipment for can be challenging. Sometimes the workers don't have the solutions when needed, as I showed in that one example with the extension for the spray can. And sometimes the workers don't use the solutions even if they are available. Sometimes the specialty contractor feels the solutions are too costly and will use a lesser solution. And sometimes the specialty contractor is not on board, is not helping the worker plan for providing the optimal equipment and tools needed for the job. And furthermore, the primary contractor may not help with the planning and scheduling of the workers, so the workers are able to have adequate time to complete the task. Or they may not aid there may be a challenge with specialty contractors working in the same space, or just a lack of coordination of the specialty contractors. So this describes many of the barriers. So we have solutions to many of the ergonomic problems, but we also have a lot of challenges to overcome in order to make those solutions work at the work site. So here I'm proposing a conceptual model, or just the way we think about how to solve reduce injuries. On the right side of your screen, we have lagging indicators, which are commonly described as just injuries. So we all know that injuries are a problem on the work site, and it's our goal to reduce those injuries. And on the left side of your screen, the way we go about reducing them is by designing a safety program that's actually giving the workers and management the information they need to perform the task so that the work is reducing the risk for the injuries. The leading indicators in the middle are actually an interim measurement that oftentimes contractors will use in order to know whether or not the safety program is being delivered as designed. And it is thought that the leading indicators are precursors or will show whether or not the workers are at greater risk of injuries. Many contractors do not have very many injuries. These are common among small contractors. And so even though their workers are at risk of injuries, and the workers may not be reporting the injuries, using injuries as the only metric to decide whether or not you need to implement a good safety program, you may be remiss in thinking that there is no problem on your work site. So instead, contractors should consider using leading indicators, which shows that the safety program that they have developed is actually being implemented. Safety programs, then, are a collection of safety activities, but it is also how those activities are delivered. Examples of leading indicators may be the number of inspections that are performed to show that the workers did or did not follow through with the safety activities on the job, or the number of individuals that were trained in a particular technique. And of course, lagging indicators are recorded on the OSHA log. So using this framework, we're going to go forward and talk about an ergonomic program. In addition to designing just the safety program, it is important to think about how the program is delivered and whether or not the program is doing what you intend for it to do. And we can determine that through the Safety Management System Plan, Do, Check, Act cycle. This cycle is in essence, says that you have planned the safety program activities that you want to deliver on the site. You deliver the programs or do the program as you intended. Then you check or look at your leading indicators to tell whether or not the program has been delivered as intended and is giving you the results that you want. And if not, then you need to act and make changes. Unfortunately, many ergonomic programs, even though we have high risks, they're often not implemented in the Plan, Do, Check, Act format. They're often single, one-time only activities that are delivered at the work site, such as a toolbox talk or bringing a tool out to the site by a vendor and seeing whether or not that tool is of interest to the workers to use. An integrated system requires not only the activities to be delivered, but then for those activities to be monitored on a regular basis. So that brings us to the case study. So I partnered with one general contractor, and much of what I'm going to present today is at a general contractor level. However, specialty contractors, even small contractors, can gain much by following the program that I'm going to lay out today. Using the framework I just described with the safety program, leading indicators, and lagging indicators, the general contractor, it was suggested to the general contractor to review the ergonomic activities and information that they had in their program. These would be examples like how many times was ergonomics the topic in a meeting or brought up as one item in a meeting. Then the leading indicators were to look for measures that included ergonomic activities. This could have been how many times ergonomics was assessed on an inspection, or how many times the daily pre-task logs included ergonomic risks and controls, or how many times toolbox talks covered ergonomic topics. And then the lagging indicators, of course, are the injuries, and these would be listed on under overexertions or as sprains and strains. So we worked with the general contractor to have him follow through and identify these three areas in their program at the beginning of the project. And what they found was safety was integrated into each of the construction activities. And here by safety, I'm primarily referring to the Focus 4. So they identified falls, struck bys, confined space, and electrical hazards and controls in all of their safety activities, pre-construction meetings, in their training, in their weekly meetings, through hazard identification and controls, through the recognition program, and they had enforcement and accountability for all of those safety risks. But ergonomics was not very apparent in their program. They did not have ergonomics listed on their pre-construction meetings. It was not discussed in their weekly meetings. In fact, there were very few activities that referenced ergonomics in their safety program. The second area that we looked at were leading indicators, and this general contractor looked at their pre-task forms, how many of the daily forms completed by the specialty contractor included information related to safety or ergonomics. For safety, we looked at the topic of falls, and that's what I'm presenting today. 40% of the pre-task forms identified falls as a hazard in their job, in their daily job, and 96% of those hazards included adequate controls. So they were doing a very good job of identifying proper controls for falls. But for ergonomics, manual material handling, 45% did recognize manual material handling as a hazard, but only 19% of those forms indicated a mechanical assist or a good control for that risk. He also looked at the number of times toolbox talks covered falls as a topic, and 18% of the toolbox talks covered falls, whereas only 3% covered ergonomics. Finally, he reviewed his injury logs, and 25% of all the non-fatal injuries were due to sprains and strains. And then within the sprains and strains, 47% of them were overexertion related to manual lifting. 27% of the sprains and strains related to working below knee, and 17% related to working above shoulder. So in this general contractor, we found the risks are very similar to many other contractors' data that we see. And so those three issues became the focus of the ergonomics program. And their goal was to focus the ergonomics program on those three exposures, but also to keep it simple. They wanted to keep the program as simple as possible. So down below, the first one, the program focused on manual material handling. The second focus was on working below knee, and the third one was working with hands above head. This study was conducted as part of research. So the researchers also conducted several investigations that a contractor would normally not do, but could probably get some of this information by interacting with the workers. We conducted several focus groups and found that workers felt they had to figure out the best method for performing the work themselves. In other words, they were left up to their own, it was left up to them to figure out how to get the job done in any way that they could. Sometimes they acknowledged that the general contractor helped. In particular, this general contractor kept a very clean work site, and that was a big asset for the specialty contractors. In another situation, the general contractor built crates to help lift equipment to higher floors before the buck hoist was installed. With foreman interviews, we found that the foremen felt there were very few references made or interactions made discussing ergonomics, although they did identify situations where the general contractor had stopped guys from carrying an object that seemed to be too heavy, or maybe the worker was being placed at risk. So the general contractor was involved with ergonomics, but not in a systematic way. So a review of the program, the general contractor had a well-developed safety program. There was little reference to ergonomics in documents and in interactions. The workers had difficulty using best ergonomic practices. Common barriers were things such as lack of equipment, schedule issues, staging, manpower, etc. So moving forward, they developed an ergonomic plan that focused on the 3 ergonomic exposures I've already described. The next step was to incorporate information into all the written materials and procedures on ergonomics, similar to at the same level they had information in the other Focus 4. They also had to gain approval from management, the Upper Management Safety Committee, on the whole program, and then they had to roll it out to the organization. And the first step for rolling it out to the organization was to educate all the workers on ergonomics and on the program. And this is a simple diagram of the program. The program involved planning, having the general contractor, subcontractors work together to plan ergonomic controls, training all the workers in recognizing and implementing controls, communicating a plan to all workers during meetings and by signage, and then review a process to monitor the effectiveness of the plan. And this system, this ergonomics program that I've now laid on top of the safety management system, is very similar. There's a planning element, there's a doing element, which in this case primarily focused on training and communicating, a review, which is check, and then modify, which is act. This is a very large number of activities that this general contractor changed. Under each one of those categories, there's a number of items that over time, it took over a year to make these changes in all of the documents and in the procedures, but they undertook, they made all of these changes eventually. A smaller contractor would certainly not have the time and maybe be empowered to make all of these changes, but these give you an idea of some of the changes that you could consider in your own safety program. Another important element was to consider all stages of construction in the ergonomics program. The ergonomics program is not only the period of time during the construction on the project. It begins before the work even comes on site, at the time the bid is placed, where the contractor must consider what are the ergonomic needs and have they actually accounted for the cost of the equipment needed in the bid. A second area before entering the work site was the subcontractor planning for ergonomics in their site-specific safety plan, and again, making sure there are procedures in place and the workers will have the equipment they need at the time they need it. And then this information was also shared and discussed with the general contractor during the pre-construction meeting. At the start of work, workers were oriented to the site and they also reviewed ergonomic principles. And there was also a discussion about ergonomics between the general contractor and the workers who attended orientation and foreman training. And then during the project, there were daily PTSAs, or daily hazard assessment forms, completed by the foreman and reviewed with all workers prior to all work. It was important that those forms included information on ergonomics. It was also important that there were opportunities to discuss ergonomics in the weekly foreman meetings and during all daily interactions. Here is the example. This is from the worker training, the topics that were shared with all of the workers. It covers the 3 problem areas. It talks about how to plan for each one of these areas in the forms, including the daily task forms and team communications. But most importantly, the orientation also discussed controls for soft tissue injuries or ergonomic injuries. Manual material handling was a primary focus and a discussion about the equipment that was used and available with each of the workers as they entered the site, asking workers what equipment they had and how they plan to perform the task using mechanical assist rather than manually handling everything was a big part of that conversation. And then the bottom point there is good housekeeping and how important it is that everybody keeps the floors clean, because you cannot use carts when there is a lot of debris on the floor. Again, we created this graphic to help combine the hierarchy of controls with the 3 hazards. The ergonomic hazards is in the table to your right: manual material handling, working below knee and arms overhead. And then we gave the workers an idea about what an engineering control would be for each one of those 3 hazards, and as well as what a work practice control might look like. Again, trying to reinforce the idea that even though PPE, stretch and flex, wearing knee pads is a control that must be used in some such situations, we wanted them to try to think about higher levels of controls for each one of the 3 hazards that we were focusing on. This eventually became a sign that was posted on the site. And then after the program was underway for a period of time, we had the first review. And so this table gives you, again, an example of the train, plan, communicate, and review on the left side, which are the elements of the program. For each one of those categories for the program, we had different elements. So under train, we looked at the annual training of the workers as well as the frequency of toolbox talks. Plan was pre-construction. This happens to be one of the elements that I had data on at all points in time, so that's what I'm presenting to you. Communication, subcontractor meetings, and safety committee meetings, and then injury review were the sprains and strains. So the control period was when the contractor was actually reviewing his project and determining whether or not he had ergonomics in his project and what that looked like. We examined the data from that period, from July to the following April, and we found that 4% of the time ergonomics was a topic compared to 11% of the time falls was a topic for toolbox talks. We looked at pre-construction meeting to see how many times ergonomics was discussed. It was discussed 6 out of the 50 pre-cons that we monitored. There were some elements of this review that were research data, and we conducted worker surveys in order to assess the information in subcontractor meetings and safety committee meetings. However, I believe that information could be gathered a different way from a practitioner's point of view. So those were actually fairly high. 34% were subcontractor meetings, and 64% of the time safety committees said they discussed ergonomics. And then there were 28 sprains and strains during that period. Then we looked at the intervention period once the program was underway. 90% of the individuals were trained with it during the first period, so this is now from July to the following January. We saw no change in the frequency of toolbox talks for ergonomics, slight increase in falls, but not statistically meaningful. No change in pre-cons. There was definitely an increase in the subcontractor meetings, communications about ergonomics. Safety committee was about the same, and number of sprains and strains was about the same. So we went back and looked at the program that we had implemented and made additional changes to the documents as well as to communications to the staff and all of the workers, trying to increase the areas that we felt would improve the knowledge and the follow-through on ergonomics. Then we reviewed the data a second time. This is now going from February of this past year till July. And now we start to see an increase in the frequency of ergonomic toolbox talks. There was also an increase in the number of falls. There was only 2 pre-cons conducted, and one of them did discuss ergonomics. Subcontractor meetings had a decrease in that period. No change in safety committees safety committee conversation. But you can start to see that these leading indicators are to help you see whether or not your program is having the effect that you're trying to get. And that's the point behind leading indicators, is how well are things panning out. This list that I'm showing you is only an example of many indicators that we followed, and we included, there were inspections on the site that were conducted, as well as a review of those pre-task plans. Here are examples of some of the good observations that the staff saw. They took pictures and they shared that, and I think that's really important. They not only shared that with the workers on the site, but they also shared that across the whole contractor, using carts, using wheels as much as possible. Either putting, on the left picture you see they're using a dolly to transport the trash can. You can just put wheels on the bottom of the trash can. The individual on the right side had to do prolonged buffing on this surface, and he's on a wheeled cart, so to speak, with knee pads on his knees, and he's in that position for a long time. There's also a chest support, so that's holding up his back, or supporting his back. So that was a very innovative solution that the workers came up with and were using on the site. There were many examples of carts and devices. Some of them were very novel, like the upper left was a window device to hold the windows in place while they were being positioned and installed. The upper right is a lift cart, which is wonderful and rarely seen on construction sites. The bottom right is a tilt bucket for using for a mason, but this style of device could be used for other applications. In addition, this contractor launched an ergonomic best practice recognition challenge, and those kinds of things I think are great ways to try to encourage workers to come up with ideas and to share those ideas. This is an example of an activity that is commonly done on a site, and that's screwing down or spot welding. In this case, it's screwing down a roof, and the individual in the upper left is bent over for long periods of time, and on the right, this is an extended handle device. So the device was not always there on site, and when it was not there, the contractor immediately went to the worker and said, "Where is it?" and let's get it back on site. So once the device was on, they encouraged it to continue to be used. So in conclusion on this project, we saw ergonomics is rarely integrated into construction safety program. We saw that development and integration of ergonomics into safety program takes time, and change in injuries does not happen quickly. You must get management support. You need to create a plan and commit it to paper. You need to start small with a few ergonomic activities, add more over time. And even small contractors can create a simple but effective program. I think it's critical you get worker involvement. They have great solutions. They just need your help to get them implemented. And furthermore, you need to build a culture that's focused not only on safety but on ergonomics. Here is a list of recommendations on what you can do to build an ergonomics program. In the interest of time, I'm not going to go over this, but you will be getting this with your slides. And that's all I have for you.
All right, thanks, Anne-Marie. We have a few questions already, so I'll start going through them, but please type in your questions at any point if you have any. Our first one is based on ergonomic injury statistics provided by Liberty. How many of these injuries occur with employers of 20 or fewer employees?
That's a great question, and I don't believe that they dissected the data in that way. We do know that injuries happen in smaller contractors. The problem is I don't believe they always reach the work comp, and that's primarily what the data is that Liberty Mutual and others are looking at. Oftentimes those injuries are being reported to the personal claims of the worker. And I published a paper a number of years ago to show that cost shifting, particularly for the smaller contractors. So here I think the message is that small contractors may not see a recordable on their logs, but that does not mean the workers are not working in pain and therefore probably less productive for that contractor, and in fact they may be taking more days off from work. They may have more absences.
Okay. So do you have any suggestions specific to smaller construction companies' ergonomic programs?
So there's no formal ergonomic program. I think to start with, companies should focus on MMH, manual material handling. Look at, here on this slide I have in front of you, look through the activities that you currently have in place. What are the common tasks that trade must do? What is the equipment that's available for the workers to use, or what are the procedures that are used, and is there something else available on the market? There are solutions out there. Unfortunately, they're not well publicized. I do know that OSHA is offering consulting to small companies to help advise them on how to avoid injuries. That could include ergonomics, but there's no single place where you can find that information. I've been trying to publish ideas, and you can find many ideas out in Washington. State publishes on trade-specific solutions. California has documents on trade-specific solutions. And of course, CPWR carries a large number of trade-specific solutions on their website. So I encourage small companies to use those resources to find solutions for the tasks that they must do, have their workers do, and ask the questions even to vendors. Vendors oftentimes will come up with some ideas. And again, your workers. Your workers see things on site when they're out in their interacting with others, and those solutions could be incorporated into the way the work is done on all sites, in all projects.
Okay. Was there a stretch and flex program implemented as part of the process?
No, this company already had a stretch and flex program in place, and actually one of the things that we did was we asked the workers what their opinion was of the stretch and flex program, and many of them said they felt as it helped them. I think what they mean is that it gave them knowledge about how to stretch. It's on the lowest level of the hierarchy of controls. It's more of a what do you do after you've been working in one position for a long time. You stretch out the muscles that are strained by that position. I think there was a secondary gain for the workers through stretch and flex, and that is that they got a safety brief at the same time. And I think that made them feel more positive about convening in the morning to find out where the hazards might be, special things that were happening on the site, which of course had nothing to do with ergonomics necessarily, but I think that was part of the reason they responded positively to the question about stretch and flex.
All right, thank you. Next question, in an advertised job description where it says the employee should be able to lift a certain number of pounds, what is the maximum weight that should be limited to, given your experience in ergonomics?
So the NIOSH lift equation, which as an ergonomist, that's the recommended limit, and that's what the airline industry uses for baggage, is 50 pounds, 51 pounds. There's newer information coming out where they're actually revising the NIOSH lift equation to say that even 50 pounds is too much if it's done on a frequent basis over the course of the day. So my recommendation is to try to keep the limit at 50 pounds. If the weight weighs more than that, to go to a two-person activity or to use an assistive device. I prefer assistive device for any activity that's over 50 pounds because even a two-person activity places individuals at risk, particularly for awkward sized objects.
Okay. Did you have an age range for the case study?
It was all ages, so it was normal working population.
Going back to the stretch and flex, I've seen that model with general contractor. Is it really effective in reducing MSDs?
I don't believe stretch and flex in and of itself is effective in reducing MSDs. I think what it does is for individuals who have tight muscles, it does give them relief, particularly if you have been working in an awkward position for a long period of time. For example, the bent forward posture can cause a lot of strain in the low back. And so one activity that I think is very helpful is to do what's called a reverse stretch or a slight back arch stretch to counteract the forward bent posture. But that does not eliminate or reduce the MSD. That basically repositions the body into a more normal position.
Okay. And did subs in this case participate in the stretch and flex?
Yes. Actually, stretch and flex participation was about 90%. It was very, very high.
How many injuries happened on that job site, and how many workers were there?
So this wasn't a single job site. We actually followed, this was over many job sites. I do not know, actually, the number of injuries that were on my project, but there were not very many, even though these were large sites that had, 500 or more workers.
Okay. I think that was all of the questions. If we missed anything, feel free to email me and we will answer your question offline. I did get several questions about the event recording, and I will automatically send out to everyone both the recording and a PDF of the slides and some additional resources. I did want to mention that CPWR put out recently the Best Built Plans program, which contains site planning tool, training resources, and coaching resources, all related to manual materials handling. So I'll include a link to that and just any other relevant resources from Anne-Marie. And you don't have to follow up with me to receive that, but if anyone wants a letter for proof of attendance, that you do need to shoot me an email for separately. And thanks so much, Anne-Marie. That was a great presentation. Thank you all for attending.
Thank you, Jessica.